obviously. So, let me introduce KATH, a no-coding data processing aid for genetic researchers that was made by KTU students. We talked with scientists from Harvard to identify the current problems that they meet during researches that delay results. They stated that current software tools are too complex to use them, and even without it, they lack programming skills. And from opposite side, programmers lack domain knowledge into biology and genetics to help researchers. There are a few bioinformaticians as a result, and they are really thought up after. And as a result, even world-class scientists, they have to manually collect and refactor data, and something that computer can done in 1 second, they have to spend hours on these tasks. As helping tools, currently they can use Nextflow and SnakeMake to create custom workflows. Some of them are integrated with data analysis tools, such as SpliceAI, Revel, KATH. But as it was mentioned, it's too complex for them to use. And I would like to pay your attention and table 1. First row, SpliceAI, it can be run locally, but also there is possibility to go to website and manually enter observation by observation and store results. And scientists from Harvard stated that that is how their current workflow is happening. And that's why we decided to introduce user-friendly and understandable interface to use data analysis tools. To hide all implementation ideas, details, we decided to use LLM. Currently, we tested several of them, and LLMs are really trending topic. Not every year, but almost every month, a new free tool is appearing, and the functionality is really varies. We expect this trend will be continued, and we are testing more tools to find the best fitting solution in our product. Here is what we already done. Current state of system KATH is TRL 4. We are continuing researches, but system is very close to TRL 5 to be ready for demonstration. We developed a UI. We tested Llama, developed a prompt priming module. Currently, we integrated SpliceAI analysis for DNA tool, and data collection module is refreshing each time while we are integrating more tools. But already we can store, collect, refactor all data from public DNA databases such as LOVD, GNOMAD, and Clevar that were requested by Harvard. Current idea is that user from UI asks Llama or prompts for some request. Llama is primed with the prompt priming module, and it generates a script that passes to script executor, and script executor has access to the rest of the system. It can run tools, collect data on the needs of user. All system is stored, is deployed on Google Cloud. And let's talk about UI. This is current idea and almost implemented. We wanted to provide for users the ability to have workspace to view files and manage them. And also we decided that user interface should be as similar as possible to the current solutions of LLMs to make it more user-friendly. In future, we will develop more features for user interface, for editing sheets, viewing code-generated sector, and so on. A very important part of our system is the prompt priming module, it automatically goes to the whole system and collects documentation that is stored in standardized documentation files. Also, for our code, we wrote such documentation as well, and prime prompt then goes to LLM, and LLM can use it to generate script. For testing LLMs, we created a very simple prime prompt. We described what LLM can do, what functions it can do, and what each function does. And we decided to have very simple input. We asked it to download data from CleanWire and LVD databases, merge data, convert to special VCF format, and pass to Splice AI DNA analysis tool, and then display results. We tested Llama 3 for comparing unprompted and prompted output. For unprompted, we can see that generally it performs well. It didn't know what functions to use, therefore it created itself. But there are some small issues. For example, input is not used anywhere after getting it, and also it didn't display results. After prompting, we can see that names of functions were replaced as we requested, but in general, the whole answer got worse. If I will run this code, I will get completely nonsense. We tested also different tools. For example, ChatGPT. For unprompted, it gave a pretty different result. We can notice that unlike previous output, ChatGPT imported libraries for working with data, such as pandas, PyBet tools to work with genomic files, and subprocess to run Splice AI. Subprocessing of Splice AI is correct. It will be successfully run, but previous code is not good. But we can notice that after prompting, it outputted very clean and nice code. This code is absolutely correct. If I will run this, it will give requested output. For other tools, as free alternative, free LLM open source Dolphin also gave us correct code. And we can see output from Splice AI that we integrated in our system. It works as intended and successfully runs, giving us validation of our system. In future, we are planning to fully implement this architecture. Entry point in system is user interface, from which user can enter database and prompt priming modules to update prompts prime for their needs, and also prompts to user assistant LLM. Introduction of user assistant LLM was made to simplify working with our system. And from user assistant LLM, data goes to script generating LLM that already will generate code and pass it to the next steps of the system that already were described in previous diagram. Script executor will get access to tools API and will execute them, and already there have access to databases, and database gets data from public databases using our written data collection and refactoring module. In conclusions, we created a system architecture. Currently, it is in TRL4 state. We proved validity of our approach, of our solution, and further prompts research will be done, analysis of specialized LLM models, and we will integrate modules to work with for DNA analysis researchers. We expect with the current space to develop TRL7 products by the third quarter of this year for Harvard scientists. And thank you for your time. I finished my presentation.